In this video, we're going to learn about rotations in the coordinate plane. So for the first thing to make note of here is that anytime we're doing a rotation, they can occur in two different directions. So rotations can be counterclockwise, so going opposite the direction of the clock, and then clockwise, going the same direction as the clock. We always are going to assume that rotations are done in a counterclockwise motion unless otherwise stated. So typically what that means is positive angles are going to be counterclockwise versus if you see a negative angle, that really is telling you to do a clockwise motion. Even if the word clockwise isn't there, if you have a negative angle, this is like the one time that you can have a negative angle, and that tells you that you're going in a clockwise motion. But otherwise, if it doesn't specify, you're always assuming to go counterclockwise. But usually you should be told which direction, or when you're describing a rotation, you should be specifying which direction you're going. So then the notation for rotations is a capital R, because lowercase r stands for reflections. So capital R, the first thing you notice here is a coordinate, is an x comma y. That's going to be your center of rotation. So that's going to be important because that's going to tell you how you're moving, or where you're moving from, I should say. And then the angle of rotation is this symbol that we call theta. So this is theta. That's the symbol. That's just a common letter that we use to represent angle measures. But this is the angle of rotation. So that's going to tell you how many degrees that you're turning your object. So you always have to know your center of rotation, the angle of rotation, and then the direction. Like I said, though, sometimes direction might not be specified using this notation. So if it's a positive angle, you're assuming it's counterclockwise. Negative would mean clockwise. Otherwise, it should specify which direction you're moving. So then when we actually go to do these rotations on a coordinate plane, there's three different angles that you're going to be dealing with. So there's 90 degrees, which means that you're only moving one quadrant. There's 180 degrees, which means we're moving two quadrants, because really that's 2 times 90. And then 270 would be 3 times 90, so that means you're moving 3 quadrants, because each quadrant has 90 degrees in it. So those are different degrees that we're going to be dealing with. Now you could also be dealing with negatives of these, which just means you're going the opposite direction, but it's still the same number of quadrants. So the other thing, when we actually move, we're always going to move from the center of rotation. So you have to figure out how many quadrants you're going to move, and then you're going to start at the center. And then what you're going to do from the movement from the center is, if it's 90 or 270, you're going to flip the movement, and I'll explain what this means. So this means you're going to flip movement. And then 180 degrees, you're going to use the same movement, because really what that means is you should be using the same slope, because you're on the same line, because you're going 180 degrees, versus 90 and 270, those are creating right angles. So you're creating perpendicular lines with negative reciprocal slopes. So this is another piece to rotations that's going to matter here in a minute. So let's go ahead and let me kind of explain a little bit further with an example of what I mean by all of this stuff. So the first thing here is we're starting with point P, so that's going to be 4, -3. So I'm going to get that on my graph, and I'm going to label it. We want to find the image of this after this rotation. So this means that our center is at 0, 0. We're going to rotate 180 degrees. That's the angle, which tells me two things. It means I'm going to have to move this point 2 quadrants. And it also tells me that I'm going to use the same movement from the center when I go to find the rotation. So our center is going to be a very important point, because if you remember doing your discovery, you found that the center and each pre-image and image point are always equidistant. So that tells me the distance that I'm going to have to travel. So point P has to move 2 quadrants, so that means it's going to move 1, 2, and remember we're always going counterclockwise unless we see a negative angle or it tells us. So I'm going counterclockwise, and that means I have to move 1, 2 quadrants. So P prime is going to end up in this quadrant over here, and what I'm going to do is I'm going to use the same movement. So that means I need to start at the center, and I'm counting over 4, down 1, 2, 3. So over 4, 3, or horizontal 4, vertical movement here is 3. So that means when I'm in the second quadrant, I have to repeat the horizontal movement and repeat the vertical movement. So horizontal has to stay 4, and my vertical movement has to be 3. But I need it to end up in this quadrant. So that means I'm going to be going left 4 and then up 1, 2, 3. And that's where P prime goes. And now if you imagine connecting this angle or making this angle with the center being the vertex of your angle, you see that you have a 180-degree angle, which you should because that was the rotation. So my horizontal and vertical movement stays the same because I'm doing 180 degrees. So in the end, my points should be on the same line. So my answer here for P prime is going to be -4, +3. So let's try another one. So now I'm going to take, again, the image of P. So I'm always going to be starting with this green point, and the center is going to stay the same, and I'm going 90 degrees. So 90 degrees tells me I need to move it 1 quadrant this time, and I need to flip the movement. Because again, I need those negative reciprocal slopes is really why we're flipping the movement. And we always need to use the same distance because from the center, those points are always equidistant from the center. So point P needs to go 1 quadrant counterclockwise. So this time it's going to end up here somewhere, or it's going to end up in this quadrant. So P prime is going to end up here, or P double prime, I should say. So what I'm going to do is I'm going to count that horizontal movement. So it's horizontal 4, vertical movement is 3, but I have to flip it. So instead of being horizontal, so my horizontal movement was 4, vertical was 3, I need to switch that. So that means the horizontal is going to be 3, and the vertical is going to be 4. So horizontal 3, vertical 4. And remember, the reason why I'm going in this quadrant instead of any of these other quadrants is because I knew that's where it had to end up. So I'm just switching the movement. So 3, then 4. And this is going to be P double prime. And now if you look, if you imagine connecting and creating the angle, see how you can see a 90-degree angle, negative reciprocal slopes. That's why you have to flip that movement. So this is going to be P double prime, which is 3, 4. And then for the last one here, again, we're going to start with P. We're going 270 this time. So if we're going 270, that tells us 3 quadrants. And we're going to flip that movement. So I'm going 1, 2, 3 quadrants. So this is where P triple prime goes, because I had to go 3 quadrants from the original. So remember the original movement was horizontal 4, vertical was 3, flip it. So now I'm going horizontal 3, vertical has to be 4, and I have to end up in this quadrant down here. So this is going to be P triple prime. So again, think about what I did. Horizontal 4, vertical 3, switch to 3, then 4. So I flipped it. So then from here, again, if you were to connect this angle, so from P to the center to P triple prime, the angle that you're really looking at is this entire angle, which that's 270. That's what we call a reflex angle because it's bigger than 180. But that's the 270. So my coordinates for that are going to be -3, -4. So keep in mind, see how I went left or counterclockwise 270? That's the same thing as saying -90 or clockwise 90. So it ends up being the same thing. So if you're really asked to go clockwise 90 or -90 degrees, it really means you're going 270 counterclockwise. So you could kind of switch that stuff up, go back and forth with it. So go ahead and try to check your understanding. We're going to do more practice with this tomorrow because it is a little bit more tricky. We're going to also look at when the center is not at 0, 0, how does that change things up? So try to check your understanding, and then tomorrow we're going to actually do a lot more practice together with this.